Hello, grade 11s, and welcome to Paper 1 Revision Part 2 of the 2015 Mathematics Final Exam Paper for the grade 11s. And boys and girls, it has been a long while. So before we even start, I would just like to apologize for taking too long to upload this. I know some of you left some comments on Part 1. Some of you went as far as sending me emails requesting Part 2 of this paper to no avail. But I want to assure you that from this month we are back and we are here to give you the best of mathematics tutorials. And with that said, I hope you will love part 2, and if so, please give us a thumbs up. Also, I would like to let you know that private tutoring is now available here on Student Tools in two categories. Either you join a group session or you sign up for a one-to-one tutoring session. So if you are interested in that, make sure you check out the link in the description. All right, now I've said too much. Let's get back to mathematics. With part 2, we are starting on question 5. Question 5, we have 5.1, which says the sketch below shows the graph of f of x equal to a minus 9 over x minus 1 minus 2. A is the point of intersection of the asymptotes of f. Okay, so we're given that diagram, and 5.1.1, which says write down the coordinates of A. Okay, so here we're given that diagram, and as we can see, this is a hyperbola, and we are required to find the coordinates of A. So how are we going to find the coordinates of A? So the first thing we will do is check out the A. A is the intersection of the horizontal and the vertical asymptote of the graph F. So now what we will do is find the asymptotes of the graph F, and then they will give us the point of intersection, or the intersection, which is A in this case. But let me take you back to the standard form of a hyperbola, which is y equal to a over x minus p plus q. So now that we have the standard form, let us observe how we get the asymptotes. So to get the asymptotes, which is the vertical one and the horizontal one, how do we get them? We have the vertical asymptote, which will be x equal to a p, and with the horizontal asymptote, which will be a y equal to a q. So in this case, that means the point of intersection will be p comma q. So with this information, let us use it to find this point of intersection, which is A. We have graph f, which is f of x equal to negative 9 over x minus 1 minus 2. So the next thing is to find the asymptotes using the graph. We have a vertical, horizontal, asymptote. So on the vertical asymptote, we will have x equal to, in this case, we had x equal to a p. Where is the position of p? P is over here. So in this case, the position of p is taken by a 1. So here we will have a positive 1. So x is equal to a positive 1. And then here we should have the horizontal asymptote. And that will be given by y equal to, let us go back to the standard form. Y was equal to a q here. And the position of q in this standard form is over here. So that means in this case, we have a -2 in that position. So that means here y will be equal to a -2. And then we get the point of intersection here will be given by 1, comma, -2. So those are the coordinates of A. Up next, we have 5.1.2. Alright, 5.1.2, determine the coordinates of the x and y intercepts of f. So here we're required to find the x and y intercepts of f. What we know is, in order to find the x-intercept, what do? We'll make y equal to 0. And when we need to find the y-intercept, x equal to 0. But first, let us find the x-intercept. So we have graph f, which is f of x, equal to -9 over x minus 1 minus 2. So here, what we will do is make y equal to 0. But we don't have y here. We have f of x, which is the same as a y. So we will make this f of x equal to 0 and equal to -9 over x minus 1 minus 2. So the next thing is we will have to simplify this. So we'll have to multiply everything by x minus 1. So x minus 1, x minus 1, and x minus 1. So here we're still getting a 0 equal to this will cancel this, such that we will be left with a -9. And here we have -2 multiplied by x, so that is minus 2x. -2 multiplied by -1, we have a positive because we are multiplying a minus and a negative and a negative. So it's a positive 2. So next step is we will take the -2x from the right hand side to the left hand side. So we will add 2x. Why? Because it's negative here. So when we do that on the right hand side, we will have to do it on the left hand side. Plus 2x. So here we will have positive 2x equal to -9 plus 2, that is a -7. Alright, so we have 2x equal to -7. To get rid of these two, we will have to divide everything by 2. This will cancel these two, such that x will be equal to a -7 over 2. So what does that mean? That means our x-intercept is at -7 over 2. So now we have the x-intercept. Now let us find the y-intercept. So we have f of x equal to -9 over x minus 1 minus 2. So remember, in order to find the y-intercept, we have to make x equal to 0. So here we will have to find the f of 0. So it will be equal to -9 over x we substitute with a 0, minus 1, minus 2. So f of 0 equal to negative 9 over 0 minus 1, that is a negative 1, minus 2. So f of 0 equal to a, this is the same as a positive 9, minus 2. So f of 0 is equal to a 7. So right now we have these. We do not have the coordinates. We have the x and the y values of the x and the y-intercept. To write the coordinates of the x-intercept, we will have 7, negative 7 over 2, comma, 0 as the x-intercept. And this side, we have to write the y-intercept. 7 is not the coordinate of the y-intercept. It is a y value of the y-intercept. So to write the coordinate, we will have 0, comma, 7. So this is the y-intercept and this is the x-intercept. 5.1.3, write down an equation of the axis of symmetry of F that has a negative gradient. Alright, so we know with hyperbolas, we have two symmetries. So we have one that has a positive and one that has a negative gradient. So in order to find the axis of symmetry that has a positive gradient, we have y equal to x plus c. We use that formula. And we have an axis of symmetry that has a negative gradient. So the formula we use for that one, we have y equal to minus x plus c. So in our case, the question required that we find the axis of symmetry which has a negative gradient. So the one that goes through here. So how do we find that equation? For the first question, we were required to find the coordinates of A, which were 1, 2, negative 2, I mean. So we would use those coordinates to find the equation of the axis of symmetry. So we will use this formula because we want the one which has a negative gradient. So y equal to minus x plus c. For the value of y, we will substitute with a negative 2. So negative 2 equal to minus x. So for the value of x, we will substitute with 1. So we will have minus 1 plus c. So to find the value of c, we will have to take this minus 1 from the right hand side to the left hand side. So we will add 1 both sides. Such that here we will have a negative 2 plus 1, which gives us a negative 1 equal to c. So c is equal to negative 1. So that means back to the formula, which is y equal to minus x plus c. We will do this. We will have y equal to minus x plus c. Now we know the value of c, which is negative 1. So it will be negative 1, but we cannot have this. So that means we will have y equal to minus x. The sign that wins this is minus 1. So that is the equation of the axis of symmetry, which has a negative gradient. And that's how we do it, ladies and gentlemen. Up next, we have 5.1.4. Alright, 5.1.4, hence or otherwise, determine the coordinates of a point that lies on F in the fourth quadrant, which is the closest
to the point A. Okay, so here we are supposed to determine the coordinates of a point that lies on F in the fourth quadrant. All right, so where is our fourth quadrant? This is the first, second, third, and this is the fourth. All right, so now we know that we have to find our coordinate right here on the graph F. So here we were told that this coordinate we are looking for, it is the closest to point A. So that means that coordinate is where the graph curves, or it's the turning point of this curve, which can also be determined by this axis of symmetry, which we got on the previous question. This is the equation of the axis of symmetry, which is y equal to minus x minus 1. So I think we can use that equation to get the closest point because it's where these graphs meet. So let us try to find the coordinate by solving both equations simultaneously. All right, so we have the equation of the axis of symmetry, which is y equal to minus x minus 1. And we also have the equation of the graph, which is f of x equal to minus 9 over x minus 1 minus 2. But this time, let us not use the f of x. We will use y equal to minus 9 over x minus 1 minus 2. So we have these equations and we want to solve them simultaneously so that we can find a point where they meet, which happens to be the closest point to A, because this axis of symmetry passes through A. Okay, so this is what we will do. Because here and here we have y equal to that and that, we will have minus x minus 1 equal to negative 9 over x minus 1 minus 2. Okay, so let us do away with this fraction. We will do that by multiplying everything by x minus 1. X minus 1 we multiply, and here let's put this in brackets and multiply it with an x minus 1. So now let us multiply here. Minus x multiplied by an x, we have a minus x squared, minus x multiplied by a minus 1. So because we're multiplying a negative and a negative, that's a positive x. Okay, now we have minus 1 multiplied by x, that is a minus x. Minus 1 multiplied by a minus 1, that is a positive 1. All this is equal to, so here we have this x minus 1, which will cancel that one. So here we are left with a negative 9. And here we have a minus 2 multiplied by an x. So that's going to be a minus 2x. And negative 2 multiplied by a negative 1, that is a positive 2. Okay, now we have a minus x squared, and this plus x minus x will be equal to 0. So here we are left with a plus 1 equal to a minus 9 plus 2, that is a negative 7. So we bring down the minus 2x. Okay, right now we will take everything on the left hand side to the right hand side. So we'll start with the minus x squared. To take that, we will have to add x squared. So we do that here. We also have to add x squared over here. And then we also have this plus 1, which we will subtract over here. and also subtract on the right hand side. So this side will be left with a 0 equal to, let's start with the positive x squared. We'll have x squared minus 2x, and we have negative 7 minus 1. That is a minus 8. Okay, now we have 0 equal to x squared minus 2x minus 8. In order to solve for x here, we need to factorize. So 0 equal to, because we have a quadratic equation here, let us put 2 brackets, and here we'll have an x, also here have an x. And then we have to find the factors of 8. Factors of 8, we have 1 and an 8. We have a 2 and a 4. So right now we have to choose a pair which when multiplied will give us a negative 8, but also give us a negative 2 when we add that pair. So that means we can go with this pair, but the 4 has to be negative. Why? Because when we multiply 2 with a negative 4, we get a negative 8. And when we add 2 and a negative 4, we get a negative 2. So that means we can use that pair. So we will have a plus 2 and a minus 4. Okay, right now we have x plus 2 equal to 0, or x minus 4 equal to 0. So here we solve for x. We take the positive 2 from this side to that side. So we'll subtract 2 and subtract 2 over here as well. This will be equal to 0. X will be equal to a negative 2. Or again here we have to solve for x. So this side we will add 4 because it's minus 4. So because we did that on the left hand side, we will also add the 4 on the right hand side as well, such that we will be left with an x equal to a positive 4. So x is equal to a negative 2 or a positive 4. So right now we have these two values or x values, which could give us the coordinate which is the closest to point A. But we were told in the question we should determine the coordinate which lies in the fourth quadrant. So which of these x values lies on the fourth quadrant? It is the x minus 4, not this one. So right now we can find the y value of the coordinate closest to the point A, but also on the fourth quadrant. So right now we will use the equation of the axis of symmetry to find that y value. So the equation of the axis of symmetry is y equal to minus x minus 1. And then right now y will be equal to a minus x. So right now we will substitute the x with a 4. So let us substitute that with a 4, and we have a minus 1 here. And y will be equal to a negative 4 minus 1. And then y is equal to a minus 4 or a negative 4 minus 1. That is a negative 5. So that means our coordinate is 4 comma negative 5. So that is the coordinate of the point that lies on F and in the fourth quadrant, which is the closest to the point A. So that is how we do it, ladies and gentlemen. All right, up next we have 5.15. 5.1.5. The graph of f is reflected about the x-axis. To obtain the graph of g, write down the equation of g in the form of y is equal to something. All right, so we have the graph of f. f of x equal to a minus 9 over x minus 1 minus 2. So in this question, we're told that the graph of f, this one, is reflected about the x-axis to obtain graph G. There are two rules that we need to understand, that if we reflect about the x-axis, what do? You negate y. And if you reflect about the y-axis, what do? You negate x. So here we are told that the graph of f is reflected about the x-axis. So what does that mean? That means we will have to negate our y. So that's what we will do to get the equation of graph G. But then we are told that we will have to write that equation in the form of y is equal to something. So let us do that. Let us first write the graph of f as y equal to something. So that is y equal to negative 9 over x minus 1 minus 2. Because we are reflecting about the x-axis, this is what we will do. We will negate y. So let us negate y. Okay. And then what's next? The next step is we have to make this y positive. And how are we going to do that? We will have to take the y from the left hand side to the right hand side, and take everything on from the right hand side to the left hand side. So let us do that. We will add y here and also add y over there. So this will be equal to 0. So 0 is equal to a minus 9 over x minus 1 minus 2 plus y. So right now we have this, and the next step is to take these from the right hand side to the left hand side. So let us first take this minus 9 over x minus 1. We'll do that by adding 9 over x minus 1. Why? Because we have a minus over here. So we will have a positive 9 over x minus 1. And again, we have to take the minus 2 from the right hand side to the left hand side. So here we will have a plus 2. All this is equal to y. So that means we can also write this equation as y equal to a positive 9 over x minus 1 plus 2. Okay, so that is how we reflect the graph of G about the x-axis. And that gives us the graph G, but right now we wrote it as y is equal to something, which is 9 over x minus 1 plus 2 over here. All right, now we're done with 5.1. Let us proceed to 5.2. 5.2, given h of x equal to 4 multiplied by 2 to the power minus x plus 1. 5.2.1, determine the coordinates of the y-intercept of h. Alright, so we have an equation of an exponential graph, which is h, and h of x is equal to 4 multiplied by 2 to the power minus x, close bracket, plus 1. So 5.2.1 says we must determine the coordinates of the y-intercept of h. So we also have a rule considering y or the x-intercept. When we want the y-intercept, what do? We make x equal to 0. So we will do the same thing here. So we have this graph of h of x equal to 4 multiplied by 2 to the power minus x, close bracket, plus 1. So to get the y-intercept here, we have to make x equal to 0. So that means we will have to find the h of 0, which will be equal to 4 multiplied by 2 to the power minus x. But right now we have to substitute with a 0. We close the bracket, plus 1. H of 0 is equal to 4 multiplied by everything to the power 0 is equal to 1. So here we will have a 1 in bracket plus this 1. So h of 0 will be equal to 4 multiplied by 1, that's a 4. We bring down the 1, so h of 0 is equal to a 5. Okay, now so we have h of 0. What we're looking for are the coordinates of the y-intercept. So we need to get the coordinates. What we know is for the x value, we already have a 0 because here we made x equal to 0. The y value, that means it's the 5. So the coordinates of the y-intercept of h is 0, 5. Okay, 5.2.2. Explain why h does not have an x-intercept. So h does not have an x-intercept. Here we are required to answer why we say h does not have an x-intercept. Okay, so we have our graph h, which is h of x equal to a 4 multiplied by 2 to the power minus x, close bracket, and a plus 1. And according to the standard form of an exponential graph, we write it as y equal to a multiplied by b to the power x plus q. So one thing we must note is that whenever we need to identify an asymptote, which is usually the horizontal asymptote on the exponential graph, we determine it using the q. So usually the horizontal asymptote is equal to the q. So y is equal to q, which would be the asymptote, the horizontal asymptote. And then here on the graph of h, we have this positive 1 representing the q, which is on the standard form. So that means the asymptote of this graph is at y equal to a positive 1. So let's say we sketch this graph. And we have our x-axis and our y-axis. And here we have 1, 2, 3, 4, 5, 6. And we determine the asymptote of this graph, which is y equal to the positive 1. So let's say our graph is going to look like this. So it's not going to go further down. It's just going to approach the 1 but not intercept the 1, or it won't go further down to the x-axis. So that is why we say the graph of h does not have an x-intercept, because it has an asymptote just above the x-axis, which is at y equal to the positive 1. So that is why, ladies and gentlemen, the graph of h does not have an x-intercept. So you can put it in writing however you want to put it, as long as you would mention that it's because graph h has an asymptote at y equal to 1, so it cannot go further down to intercept the x-axis. Okay, up next we have 5.2.3. 5.2.3, draw a sketch graph of h clearly showing all asymptotes, intercepts with the axis, and at least one other point on h. Alright, so here we are supposed to draw a sketch and show asymptotes, intercepts, and at least one point. Okay, so what do we know? We do know that the y-intercept is 0, 5. We got that from question 5.2.1. And we know that we have an asymptote. If you don't know how we got the asymptote, go back to the previous question, which is 5.22. You will know how we got the asymptote. And the asymptote here is y equal to a positive 1. Also, we were told in the question that we should determine at least one other point on graph h. So let us try to get at least one point on the graph of h. So we have graph of h as h of x equal to 4 multiplied by 2 to the power minus x minus plus 1. So let us say maybe we want h of 1. So that will be equal to 4 multiplied by 2 to the power minus x. But then we will substitute with the 1, positive 1, and we close the bracket, plus 1. So h of 1 will be equal to 4 multiplied by 2 to the power minus 1. That is 1 over 2. Close bracket, plus 1. So h of 1 will be equal to 4 multiplied by a half, that is a 2. Oh, we forgot the 1 here. So we have to bring down that 1. So h of 1 is equal to a 3. So this point, which is on graph of h, will be 1, 3. Right, so now we have the information that we need. Let us try and sketch this graph. Let us draw our axis, y-axis, we're sketching x-axis. So here we'll have 1, 2, 3, 4, 5, 6, 7, 8. Okay, maybe let's just say -1, -2. We have 3. Also -1, -2. Okay, 1, 2, 3, 4, 5, 6, 7. All right, so what's the first thing that we will do is to draw our asymptote or sketch our asymptote. So we'll do that in red. We have an asymptote at y is equal to 1. So that is our asymptote. And we label it y equal to a positive 1. Also, we have a y-intercept. So we have a y-intercept at 0, 5. So 0, 5. So that's where our y-intercept is. And we have this other point on the graph of h, which is 1, 3. So we have 1 over here and 3, which means it's over here. So now let us try and sketch our graph. I'll use a different color. Alright, so we're sketching the graph of x. I'm sure yours will be much more prettier than mine. But it's something like that. It has to be a curve. This is not a curve. But you should learn how to draw a curve or sketch a curve. Then you label a graph h, and you also label your coordinates, which is 1, 3 over here, and the y-intercept, which is 0, 5. And that is how you sketch your graph, ladies and gentlemen. Just make sure you have your asymptote, you have your y-intercept, you also have that 1 point on graph h, and you also have labeled everything. So by doing so, you will get each and every mark that is allocated to the question. So next, we have 5.2.4. 5.2.4, describe the transformation from h to g if g of x is equal to 4 multiplied by 2 to the power minus x plus 2 in brackets. Okay, so we have graph h. Graph h is h of x equal to a 4 multiplied by 2 to the power minus x close bracket plus 1. So we're told this graph h is transformed to g, and g is described as g of x equal to 4 multiplied by 2 to the power minus x plus 2 close bracket. So we're supposed to describe the transformation from here up to here. So how are we going to do that? First, let us do this on graph G. So let's say maybe we expand this. So we will have G of x equal to 4 multiplied by 2 to the power minus x. That is 4 multiplied by 2 to the power minus x. We close the bracket, and 4 multiplied by 2, that is a positive 8. So now we have something that is a little bit identical to h. The only difference is this. So remember when we were sketching this graph, we got the asymptote as to be y equal to a 1, which we got from here. So that means if we were to sketch the graph G, we would have our asymptote where? At y equal to the positive 8. So we would have our asymptote over here at y equal to a positive 8. So what kind of a transformation is that? That means our graph h, the graph h has been shifted 7 units where it's upwards. So that is how we describe their transformation from H to G. Alright guys, let us move on to question 6. Question 6. The sketch below represents the graph of two parabolas, f and g. F of x is equal to that, and the turning point of g is c, 2,9, and the y-intercept of g is a, 0,5. B and D are the x-intercepts of f and g respectively. Right, so here we have 6.1, which says show that g of x is equal to a minus x squared plus 4x plus 5. So basically they want us to prove that the graph of g looks like that. So in other words, we have to identify it. So how are we going to identify the graph of g? What kind of information do we have about g? We know that it's a parabola. So we also know that g has a turning point at 2,9, which is c. And usually when we have a turning point, we have this formula which helps us to get the equation of a graph. We have y equal to a multiplied by x minus p squared plus q. So we use this formula when we know the turning point. So how does the turning point fit into this formula? Basically, the turning point consists of P, comma, Q, which is this one and this one. But in our case, we have our turning point, which is C. And that C is 2, comma, 9. So let us use our turning point to determine the graph of G using the same standard form. So y is equal to a multiplied by x minus p. So before, this p came from the x value of the turning point. So right now, here we will take the x value of c. So we will have a minus 2. We close the bracket and square, or to the power 2. And then plus q. Where did q come from? Q came from the y value of the turning point. So also here we will take the y value of the turning point, which is 9, and place it over here. So that means now we have y equal to a multiplied by x minus 2 squared plus 9. So where do we go from here? Do we have more information to help us identify the equation of g? Yes, we also have the y-intercept of g, which is at a. That is 0, 5. So we can use this coordinate to get the value of a. So let us try and do that. So for y, we will use 5. So here we will have 5 equal to a bracket x. X is replaced by the 0. So 0 minus 2 squared plus 9. And then we have 5 equal to a multiplied by 0 minus 2, that's a negative 2, negative 2 squared, that is a 4, positive 4 plus 9. So that means we have 5 equal to 4a plus 9. So to make a the subject of the formula, we will have to subtract 9 over here and also subtract 9 over here, such that this will be equal to 0, and 5 minus 9, that's a negative 4, equal to 4a. So now we have this, so we will divide both sides by a positive 4. So this 4 will cancel this one, such that negative 4 divided by a positive 4, that's a negative 1, equal to an a, the same as a equal to a negative 1. So from the standard form, which is y equal to a multiplied by x minus p squared plus q, our equation will look like this, as y equal to a, we know the value of a now, that is a negative 1. So negative 1, we close open bracket, x minus p, we take the x value of the turning point, that is a minus 2 over here instead of minus p. So we will say minus the 2. We square that plus q. From that, we take the y value of the turning point. So that's the 9. And this goes on to look like this. Y equal to a minus 1 multiplied by x minus 2 multiplied by x minus 2. Why? Because it's squared over here. And then we bring down the plus 9. Okay, so we have y equal to minus 1. We want to expand these brackets. So let us make big brackets over here. X multiplied by x, that is an x squared. X multiplied by negative 2, that is a minus 2x. Negative 2 multiplied by x, that is a minus 2x. Negative 2 multiplied by negative 2, that is a plus 4. We close this bracket and then bring back the 9, the positive 9. So right now we have y equal to negative 1 bracket x squared negative 2 minus 2, that is a minus 4x, plus 4. We close the bracket, plus the 9. So y is equal to negative 1 multiplied by x squared, that is minus x squared. Negative 1 multiplied by minus 4x, that is a positive 4x. Negative 1 multiplied by 4, positive 4, that is a minus 4. And then we bring the 9, which is plus 9. So y is equal to a minus x squared plus 4x minus 4 plus 9. That's a positive 5. So this is how it will look like finally. But because it's g, we can describe it as g of x equal to minus x squared plus 4x plus 5, which is the same as this. So that is just how you show that g of x is equal to minus x plus 4 plus 5. 6.2. Calculate the average gradient of g between a and c. Right, so we are supposed to calculate the gradient or the average gradient between a and c. So what are the coordinates of a and c? A is 0, 5. C is 2, 9. So in order to calculate the gradient between a and c, we have this formula, which is y2 minus y1 over x2 minus x1. When we have this as x1 and this as y1, also this as x2 and this as y2. So that means the average gradient between A and C will be equal to y2, which is 9, minus y1, which is 5 here. So we would have 9 minus 5 over x2, which is 2, minus x1, which is 0 over there. So gradient between A and C will be 9 minus 5, that's A, 4. 2 minus 0, so we will have a 2 over here, which gives us a 2. So that means the average gradient between A and C is equal to 2. And that is just how we find the average gradient of G between A and C. Alright, up next we have 6.3. 6.3, calculate the length of BD. Alright, so here we have B and D. What we can see over here is that B is an x-intercept of the graph F. Also, D is the x-intercept of graph G. So in order to determine the length from here up to D, we first have to determine their coordinates. Let us first try to determine the coordinates of B. And B is the x-intercept of graph F. So we have graph F, which is f of x equal to 1 over 2 multiplied by x squared minus 8. So we want the x-intercept of this graph. So when we want the x-intercept, what do? We make y equal to 0. So this graph of f is the same as y equal to 1 over 2 x squared minus 8. So this is what we will do to get the x-intercept. We will make y equal to 0. So this side will be equal to 0, equal to 1 over 2 x squared minus 8. So to get rid of the fraction, we will multiply by 2. Multiplied by 2 here as well, and multiply by 2 here as well. We multiply everything by 2. So 2 multiplied by 0, that is still a 0, equal to, this 2 will cancel this 2, such that we'll be left with a 1 over here. So 1 multiplied by x squared, that is x squared. And over here we have minus 8 multiplied by 2, that is a minus 16. So next we have to take the 16 from the right hand side to the left hand side. We will do that by adding 16 over here. When we do that on the right hand side, we also have to add 16 on the left hand side as well, such that this will be equal to 0, and we will have 16 because of 0 plus 16, which will be equal to x squared. So to get rid of the square, we will have to do this both sides, find the square root, and here we will have x equal to the square root of 16 is plus or minus 6.4 says use the graphs to solve for x. If 6.41, 6.4.1, if f of x is greater or equal to 0. If this graph f is greater or equal to 0. So where the graph is greater or equal to 0. So that is actually from here to there and over here. So that is where the graph is greater or equal to 0. So how do we describe that? So remember here, B, we got the coordinates of B as -4, 0. And from the previous question, we also got that the other x-intercept of F is 4, 0. So that means when we solve that, f of x is greater or equal to 0. We will say that happens at x less or equal to the -4, this one. So because that happens from here going that direction, the graph becomes greater or equal to 0, which is the x-axis. And then we also have this side. We will say f of x is greater or equal to 0 when x is greater than a +4, greater or equal to +4. So that means our solution will look like this. It's when x is less or equal to a -4, or when x is greater or equal to the +4. So this is our solution to 6.4.1. 6.4.2. Again, we're supposed to use the graph to solve for x if f and g are both strictly increasing. Okay, so here, if we would take a look at graph G is increasing. From here, it's still increasing up to the turning point. But then graph F, from here where graph G is increasing, graph F is decreasing up to here. But then from here, graph F is increasing. But then over here, graph G is decreasing. So where can we say these graph F and G are both strictly increasing? As you can see, it is over here. So from this point up to this point, both graphs are strictly increasing. So how do we put that in writing? We say graph F and G are both strictly increasing when x is greater than 0, because it's from here up to there, but less than 2, because here it's a 2 taken from the turning point. So that is how we solve for x in 6.4.2.
Well, guys and girls, that marks the end of part 2 of this tutorial. Make sure you also check out part 3, where we will be doing financial mathematics and probability. Also remember that we now offer private tutoring sessions in 2 categories. Number 1, it's a group tutoring session. Number 2, it's a one-to-one tutoring session. So if you are interested in anything like that, click on the pop-up at the top right-hand corner of your screen, or you can click the link in the description. All right, let's meet again same time right here on Student Tools on Saturday for another grade 11 video tutorial. Make sure you subscribe so that you don't miss that video. Bye-bye.